welcome to Investigation 2.2. This is called the Drought Stopper. So, I have an invention that I hope that it will help stop droughts. It's called the Drought Stopper. I know. It's
such an innovative name.
I know, truly. Okay. Now, the Drought Stopper system is kind of like a black box. We can see what it does, but we can't really see how it's working on the inside. So, what you're going to need to do is during the investigation, I want you to figure out what is going on inside of the box. So the black box, if you will, it's a model of how something works. But your job is to figure out what's going on here to cause this to happen, okay? All right, so your challenge is to draw a model that explains how you can get an additional 500 to 600 milligrams of water out after putting only 100 milliliters.
What?
So I want to take in. Okay, so again, your challenge is to figure out what's going on inside the black box. So this is called a drought stopper because by producing coming up with an invention that will take in the little bit of water that we have here on Earth that continually cycles through the water cycle, but all of a sudden, how can we produce more water than we're actually taking in? That's the big idea. Okay, so our focus question is, how might a drought stopper system work? That's our focus question. How might the drought stopper system work? Now, I'm going to make sure I'm doing this correct. So you're trying to come up with an idea of how this model works. And if it explodes, well, I tried. Okay.
Everyone be quiet.
Okay.
Why would I come?
Okay.
Does it make it its way down? It's not coming out.
Right. Now, I am going to add one more. I have added 400 milliliters of water into this container, this black box. I'm going to tape it shut. So, if you notice, whatever I just did, I took water and put it into something. 400 milligrams of water and put it into something. Yes?
Mm-hmm.
Okay. Is anything coming out right now? No. How could that be?
Something's blocking it, maybe.
You think something's blocking it? Yeah. What do you think, Esme?
The water hasn't filled up so we could go to the tube.
But I put in 500 milliliters of water. I put in 500 milliliters of water. What do you think, Dexter?
You have to go through the tube in the top.
Yeah.
Oh, okay.
Yeah, that's probably like a trigger plate.
Okay, so you think the funnel is going to trigger something?
Yeah, what else is there?
Okay.
What if it connects to something?
Okay, so now, let me
That's pretty
pour a little more. I'm going to put 300 milliliters of water. So, nothing's going on, right?
No.
Okay. I have 300 milliliters of water. I just poured water into a device, right? Okay. Okay. Is anything happening?
No. Not yet.
That's Mr. B's favorite word.
Anything?
Well, it's going down.
Okay.
Maybe there's something like water.
Oh, yeah.
Come on, I'll
Maybe there's
you can do
something
it. Blocking it, but it's waterproof, so there's no water.
Okay. Is anything happening yet?
Nope.
Okay. So I have 200 milliliters of water left. So I just added 100 milliliters. So I started with 500. I added 100, right? Is anything happening yet?
Is it gravity?
I think gravity. It's like you think the water. I think it's gravity. Maybe you have to.
Okay. I just added. So I started with 500 milliliters of water. I have now added almost 300 milliliters of water more. Nothing is happening.
Oh, it's a trick. It's a trick.
Okay.
It's a miniature name.
Okay.
I think I know.
Remember.
Drought Stopper.
Okay. Okay, I'm going to add another 200 milliliters of water. So we're at how much water is in this device?
Like 700 milliliters.
500 plus 300.
800.
Okay.
Wait, if you had two, that would be the same amount as the. Do you have to put in the same amount of water as the other, as the last time?
Oh, you think?
Balance.
Okay, so you think. So Cooper, you think that I started with 500 milliliters of water and nothing's going to happen until I add 500 milliliters more of water?
Yeah, it's probably a weight system.
Okay. So you and Kaden, you think has something to do with weight?
Kind of like how a key. You know how keys they all have to all 5 of the pins have to line up. Maybe the 2 things have to line up in order for the water to go down.
Oh, interesting. Okay.
It's gonna be something.
Oh!
Yay!
Okay.
Did I touch it?
That was about 150 milliliters of water.
That's
Famous
why you learn how to be
so
a plumber.
much. Come on, let's see. There's a Pokemon.
Okay. Okay.
That's a lot of
What's going on?
That's a lot of water. There's something that's balancing it. So only
You can
a certain amount of water. Yeah, there's a balancing. Because you know how you put it in the box the first time and instead of putting it through that, maybe you put it through that one on the other side or whatever.
Interesting.
So it would balance. It must be like 2 separate containers that both use the same too. Yeah.
Oh, you think there are 2 separate containers?
Yeah.
Okay, Dexter, what about you?
One to this one and one to the other one. Something stuck.
And then once not enough double and mainly double, it lets out.
Yeah.
Because the pressure is the amount
Yeah.
of water.
Yeah.
It lets out like a black.
Yeah.
Okay, so you think it has something to do with pressure.
Yeah.
Okay.
I
Kaden?
think that maybe there's like maybe there was something in there and then maybe there's like a spring and then but when they both align it makes the spring open, which then lets the water come through.
Ooh, okay. All right. So, with your group, number 1, how does your model operate? What does it look like? How does it operate? What observations of the drought stopper support your model? What did you see here that supports your model? So, I'm going to have the hairy spiders, the seasick dolphins, yellow shoes, what dizzy birds, or where was it? Afraid of heights birds, dizzy birds, and then what? DB?
Scared cats.
No, you guys. You could be the overfed cats. Okay. Well, Cooper likes to eat In-N-Out burgers. So. Okay, I'm going to have you guys take a few minutes, and I want you to come up with a model. I want you to tell me what it looks like and what observations that you saw support your model.
I'm lost. What do we do?
Okay, so we had 1, 2, 3, 4, 5 groups share out their ideas of their models and what they thought. Now we're gonna now do the unveiling of the black box. Okay, so I have a funnel attached to a tube.
I knew it.
Okay.
Yes.
And then
We all knew that, Johnny.
I have another tube that's inside that is curled around. It's inside, but it doesn't touch the bottom. The tube does not touch the bottom. Okay. The tube does not touch the bottom.
Correct. I thought it was smart. No, why are you standing over there? I'm standing over there too. Did it stop recording? You're still recording. Oh.
I knew it.
All right. So let me explain to you. 3, 2, 1. All right. So this drought stopper uses a siphon to produce the interesting behavior you observed. A siphon is a tube filled with water with the outflow end lower than the inflow end. The inflow end is on the bottom of the container and the outflow end extends below the level of the bottom of the container. And I did hear a lot of that conversation going on. Gravity. Yep. Daniel kept throwing out about it being lower using gravity. Now listen. Gravity makes the water flow from the lower end of the tube, just as it would make water flow if a drain were on the bottom of a container. Water will flow through the entire tube until the container is empty. Stop. Okay, when the drought stopper was set up, there was air in the tube. The system was set up so that the water level in the container was below the highest point in the tube loop. With air in the tube, gravity could not force, Daniel, you kept saying that too, could not force the water over the top of the tube. When that last 100 milliliters was added, the water was added to the container.
Push it.
All right. Now, I know this is confusing, but we'll draw this out tomorrow. The last 100 milliliters of water was added to the container. The level of the water went above the loop. So here's that loop. The water went above the loop, and the force of gravity pushed the water into the entire tube so it flowed out the other end. Daniel, you were really almost spot on so much of that. Good job. All right, that'll do it. When we come back tomorrow, we'll actually draw this out. All right, have a good day. Welcome to Investigation 2.2 called Drought Stopper. I have a black box here. inside the black box, you don't know what device or what apparatus I have in this box. What I'm trying to do is technically create an invention that would put an end to droughts. Because here in California, we are subject to droughts, which means that we don't get enough rainfall in order to supply our mountains with snow, which runs down as it melts and fills up our lakes, streams, and rivers, right? That we can pull water, fresh water from. Now, it's kind of like it's essentially a black box where the inside is a mystery. You need to figure out how this is working. You need to figure out what is going on, what kind of contraption is inside the box that's allowing water to flow. You haven't seen anything yet. All right, so your challenge as I go through this is to draw a model, and you have a little box on your paper. You're going to draw a model and tell me, how does it work? How does your model work, and how does your model go with what you're seeing here? So your challenge is to draw a model and then write an explanation of why it works. Okay, but you can't do that yet because you haven't seen anything. So I'm going to take, I have some cups in here. I have something in here. And it's not perfect because I do have a little bit of a leak. I am pouring in 500 milligrams of water. Just wait. I am pouring in 500 milligrams of water into something. Is anything happening?
Yeah.
No, not that I can
No.
see. Yeah.
Nope. Wait.
Is anything happening right now?
No. Yes. What is that one little
water is leaking
right there?
Oh,
Yes,
yeah,
oh.
it is leaking.
Okay.
I bet there's two
Well,
attached to
If that don't count that. That's a little bit of my mistake. Okay.
Oh,
So
then nothing
now I just poured water into something. And is water coming out?
No.
No. Okay. So now
It doesn't have any contraction to come out. Like it doesn't have any doors. You have to turn it upside down. Come out.
but there's
Yeah.
a tube.
That was your mistake. Yeah, but then
Okay.
you have to pour it down a little cycle and then it comes up to two. Yeah. Because there's probably two tubes in there.
Oh, interesting. Okay.
Put the water in the tube.
So our focus question is, how might this drought stopper work? You haven't seen anything yet.
Yeah, but
But you haven't seen anything yet. Okay, so now I have another 500 milligrams of water. Okay, so let's see what happens when I add 100 milligrams of water.
What?
That's
A
it.
little soft.
So now we have 600 milligrams of water. Is anything happening?
You just
Put a
wait.
liter in.
It will happen. It will
Put a
happen.
liter in.
Just wait.
Put a liter in.
Don't be shy. Put
Okay.
some more. The water broke.
Yeah, don't be shy.
Okay, is anything happening?
No.
Okay,
Don't be shy.
You're too much. Maybe it's like getting clogged up.
I don't think anything's clogged.
Add some more.
Okay, I now have 200 milligrams. I've added
Put it all.
2 mil. You don't know anything yet. You haven't seen anything happen yet.
Maybe the tube that is inside the box got clogged.
It's not.
Then why did water coming in there?
Exactly. Why isn't water coming out when I'm adding more water?
We have to see you need a certain amount of water.
It's called a drought stopper.
Interesting.
That's what I
Okay.
was gonna say.
Okay, so I've added, I started with 500. Now I added 2 more hundred. So we're at 700 milligrams of water.
Don't be shy. More. More.
Okay, I've added another 100 milligrams of water. Is anything happening?
No, add more.
I don't
know, add
know.
more. Try add more. Add more.
There is a contraption.
No,
there's a tube connected to it. When you pour the water from the tube, from the little funnel thingy, it will go down there and it will go into the tube, and that's why it's not coming out. When you poured stuff in the box, just in the box, stuff was coming out because it wasn't in the tube.
Okay, well,
Maybe you just put something
okay,
there
so now
to pretend that it's
Yeah,
a
but
drought.
I've put
Lever
200 milligrams. I've added 200 milligrams now.
Maybe you put something in at the other end of the tube to pretend
No.
it was a drought.
Okay, I added about another 100 milligrams.
I had the whole thing something might happen.
I know, I don't.
Yeah,
Okay.
that's the whole thing.
Okay.
I should know.
Okay, so now we're at 800 milligrams of water.
I thought it was 90. Yeah, that is 90.
Oh,
That's
there
a
finally broke.
That's
Okay.
1,000.
I think too much water was pushing down.
Okay,
The pressure.
so this is what you're going to do. You're going to break out into a group. You are in your group, you are going to come up with a model of what is going on inside of here. How does it work and why does it work? All right.
Oil and chunky boy.
Okay, so I'm going to come back and we're going to share out your designs. So, all right, welcome back. Students, Manuel's going to share his model. Okay, go.
Okay, so first, there's clouds and there's rain coming down. Then the funnel takes it in, and then water comes in. It needs a certain amount of level to get into this, and then this is ponds, lakes, etc.
Okay, that's a great idea, but you're modeling this, what happened in the box, and if you pour water in a cardboard box,
Well, it gets soggy.
it's going to get soggy, right?
Yeah.
Okay, Fernando, come on over.
Okay, so right here is Miss Kane pouring down the water right here, and then when she was pouring down the water, it wasn't working, and then when it went to a certain water level, it starts pouring down.
Okay. All right. Thank you very much. Okay, go Taylor.
So when we poured the water down, I think it needed a certain amount of water for it to come down into the container.
Okay, all right. Jose.
And the next one is Fatima.
Oh, Fatima.
At first, when she poured water down the tube, it wasn't enough to lead it down here. Then afterwards, she poured to 300 more milligrams of water, and it was enough to fill up the cups in the box.
Okay. And Jose.
So I think the problem was when the water didn't come out is because one of the ends of the straw was bended, and so when we filled it up with more water, the pressure of the water made it eventually get unstuck, and the water came out. But also, you filled in the box with 500 milligrams of water. Am I right?
Milliliters of water.
Milliliters of water, right? So that would have probably caused more pressure of the water to make the tube get unstuck.
Okay. All right. Thank you. Now come on back to your seats and let me explain to you what's in the black box and the model. All right. So,
There's a tube in it. Yeah, there is.
okay.
There's a tube, and
All right. Let me show you. Here is a tube. Here's a funnel with a tube. Okay. Here's a funnel with a tube. Right?
Yeah.
Okay. Now,
See?
here is the contraption inside. So, and remember, I have this taped because it cracked a little bit. The plastic cracked.
Yeah.
So now inside there is a tube that's bent over. the tube that's coming out is bent.
Oh, and then there has to be a certain amount of water. Exactly like on the paper. And over and in. Literally.
Okay. Kelly?
Wait, but then that means you were cheating. Cheater. Yeah, because you were cheating. That's why the bucket was. She's a teacher.
I asked you to design a contraption that would model what you saw.
But I don't know what a contraption is. I think the calcium and ground them.
Just a model. Okay.
We're not gonna do the Among Us character.
It's alien tape. Okay. All right. So, well, there was because I had a little crack in the plastic. That is why it. Okay. So now let me show you what it does.
You erased the best one. I know.
Eliminated.
So you guys have the worst though.
Don't delete the orange.
Okay.
No.
You guys know you're being recorded.
Okay.
Zoe, I don't have a lot of time, so I need to tell this out. And I will come back to you in a moment. Okay, so here is the container, right? All right, so there is a tube that comes around.
What I drew. Yeah, James was right.
Okay, now, then we had a funnel with a tube as well.
And then there's a little.
All right, now, when I put in 500 milliliters of water,
It wasn't enough. It wasn't enough.
there's air in that tube, and the air in the tube is
Pressure.
it's pressure. It's not allowing the water into the tube. But as I fill in more water, the water starts to rise, and as soon as this tube sinks underwater,
The water wins.
the water then now has enough air to suck in the water, and that's where it goes. So as long as this tube is not covered, the water isn't going to leave. So let me explain it really quick. The Drought Stopper is a siphon. Uses a siphon to produce the interesting behavior you observed. A siphon is a tube filled with water with the outflow end lower. So the outflow end is lower than this intake. So with the outflow end lower than the inflow end, the inflow end is on the bottom of the container and the outflow end extends below the level of the bottom of the container. Right in here. Gravity, what did I just say? Gravity makes the water flow from the lower end of the tube just as it would make the water flow if a drain were on the bottom of a container. Water will flow through the end of the tube until the container is empty. When the Drought Stopper was set up, there was air in the tube. And the system was set up so that the water level in the container was below the highest point in the tube loop. With air inside the tube, gravity could not force the water over the top of the tube. When I added the last bit of water, the level of the water went above the loop and the force of gravity pushed the water into the entire tube.
So there won the final.
Okay, so now what's your question?
Where did the water go? Really? No.
Here.
Oh my god. No. It went into the bucket. No. The air.
Okay.
That's what I mean. You put the bucket right on the bottom of no. You put it in the box. You put it in the box. Just swinging around. Your bucket was on the bottom of the box, right?
Yeah.
When you put the tube with the funnel in the box, where did the water go that went in the funnel?
Right here. So, like I started out, when I filled it up, the water did not go above the tube. Okay?
Dino Boy.
So as I added more water, it filled and went above the tube. And as soon as the tube went underwater, gravity forced the water to come out.
Okay.
Okay. That's it. Hopefully you learned a little bit how the water is forced out by gravity. And that'll do it.
That YouTube channel will actually put